foldable instructions. So we're going to talk about the properties of algebra today. We're going to talk about the multiplicative, commutative, addition and multiplication, all of that stuff. And all you guys really have to do is recognize the property. That's it. Easy peasy. They're going to show you a property and you have to identify which one it is. I can look right out my window and see my fence destruction. Oh boy. Have any of you guys ever like absolutely destroyed something? I'll have to show you guys a picture of what I did. Hold on, I'll show you. Ugh, so bad. I'm so unhappy about this. Look at this. Can you guys see my camera? If you look at my picture, yeah, that was the fence that I totally hit with my car. Not intentional, of course. My husband thought it was hilarious. Look at that. That's my car. I broke the fog light. So mad. On a high note, for my Pokemon friends out there, I finally caught a Ditto. My son was taking pictures. They're so hard to catch in that game. Yeah, it was so random. I've had that quest forever. For me, it was in a Venorat or something. That puffy purple thing. I don't know. That is what I caught, and it turned into a Ditto. All right, how are we doing with the foldable, guys? If anybody's willing, you can turn your camera on and show me. You don't have to be shy. You can see how fabulous I look today. This is the pink eye, by the way. So gross. You have to put like ointment on the inner lid of your eye. It's so weird. How are we doing though, guys? I would love a status update of how we're doing on the foldable. Oh, Emma, beautiful. Nice work. That's perfect. Very good. Thank you. Oh, no, it's okay. I'm just wondering how we're doing. It's okay. I know there's a lot of stuff on there. That's why I wanted us to have us do this ahead of time, because then when we go through the properties, you can just write it in real quick. And we'll get through it super fast. And what's awesome about today's lesson is you guys can use Desmos to your heart's content to help you. I'll put the link in chat. I also have the link in the lesson. Desmos is a really handy online calculator. Oh, typed it in wrong. There we go. So in chat, I put the link to Desmos, and we're going to talk today about evaluating expressions, order of operations, and then sometimes you'll have to use these properties. Desmos is great because you can just type it in exactly how it looks, and it'll give you the right answer. But I will explain that, and I'll demonstrate it for the lesson today. All right, I'm gonna pause our recording. I'll resume recording. We are in week 8, and yeah, we're gonna get to some real algebra stuff today. Woohoo! This is what is due this week. You have a math mindset lesson, you have properties of algebra, that's what we made the foldable about, and then order of operations and evaluating expressions. So nothing too heavy, and again, calculators are amazingly helpful, excuse me, specifically Desmos. I'm just getting closer so I can write with my little pen there. We're gonna, oh, sorry. Sometimes you guys, so I'm just gonna bring this up for everybody because I forgot to mention it. We're gonna use the foldable later. So after we talk about evaluating and order of operations, we're gonna talk about properties, and then we're gonna use the foldable. So for now, just put the foldable aside. So today, we're going to evaluate expressions using the order of operations. We're going to evaluate algebraic expressions, and then we're going to learn about the properties. So does anybody know what the order of operations is? What's the order? What is it? When we say order of operations, what does that mean? There's a little acronym there. PEMDAS, yeah, very good. PEMDAS is our acronym that we use, and that stands for parentheses, exponent, multiply, divide, add, and subtract. Sometimes I've heard people say GEMDAS. I don't refer to it that way, but it means the same thing. People will say grouping, symbols, or parentheses. Yeah, please excuse my dear Aunt Sally. That's a way to remember it. Very good. What does it mean if you evaluate something? What does evaluate mean? Like if you're told, like look at that example there, evaluate n plus 7 for n equals 4. What are you supposed to do? Right here. What are you supposed to do there? Because you're going to see that word evaluate a lot in algebra. It's a lot different than the word solve. Solve will have an equal sign. So what do you guys think we're supposed to do here? Any ideas? Do we cry? No, I'm just kidding. Do we say, forget you, algebra, and punch our computer? Don't do that, no. What do we do here? Evaluate n plus 7 for n equals 4. What do you guys think? I know in 7th grade, you guys talked about probably one-step equations. So like stuff like this, n plus 7 equals 14. And this is different than this over here. This is something you solve. Oops. And this is something you evaluate. So here, over here, I would subtract 7 from both sides, and I would find out that n equals 4. I solved that equation. But here they're already telling me what n equals. So what do you think I'm supposed to do? And remember, if you're wrong, so what? Who cares? We're learning together, my friends. What do you think? Emma says it's 11. How did you get 11, Emma? You're right. Very good. So when you evaluate something, you do get a single numerical answer. Very good. So what Emma did is she replaced the n with the 4. And then she got the answer of 11. So when you evaluate something, you figure out what the numerical value is, but it's different than solving. You're going to plug in what they tell you and figure out what it is. So it's really close to solving, but we actually say evaluate because there's no equal sign. Okay. Pardon me. Pardon my coughs. Okay, so again, these examples, what I would do if I were you, I would write them right in your assignment notebook. Not assignment notebook. Math notebook. Sorry, said the wrong word. Oh, there's Nathan. Cool. Hello, Nathan. Thank you for letting me know you're alive out there. I love it. Hi. All right. So we're going to do the same thing here. We want to evaluate 1/2 of x plus 2. And they're telling us x is equal to 16. So I'm going to, instead of x, I'm going to replace it with 16. And whenever I plug something in, I always do it with parentheses just because. In this case, it really doesn't matter, but there are cases where it does matter. So I'm going to put an extra set of parentheses. Okay, so when you're, so I replaced this x with the 16 that they told me it equals. And I always do it with parentheses because it really helps you get the right answer. Okay, now let's say we hate math, right? Who hates trying to calculate stuff? Who finds that they always get it wrong no matter what? You don't have to answer that if you don't want to. Yeah, it's frustrating. So for something like this, what's really awesome is you guys can use a really cool website called Desmos. That's this website here, desmos.com/scientific. Oops. Well, you know, that's a really good question, and it relates to thinking, it relates to a lot of things, yeah. So sometimes there's things in algebra that really don't fit into everyday life. But sometimes there are. So that's the website. Now let's say you just hate calculating things because you find that you always get the wrong answer. We are going to go through order of operations, but Desmos is really cool because you can just type it in exactly how that is. Okay, so I'm going to hit the fraction button, which is right here. Super helpful. So I'm going to hit fraction 1/2. Then I'm going to do parentheses. And then I'm going to do that extra set of parentheses just because it's really good idea to do that when you're plugging something in. Plus 2. And check it out. Tells me what the answer is, which is 9. Isn't that nice? Isn't this a sweet calculator? You guys gotta agree with me on this one. It's pretty epic, right? Yeah, it's pretty nice. I highly recommend using this calculator for your lesson because it really helps for your homework, I mean. Now, if I was going to do the order of operations, what would I do first in this evaluating? Where would I start? And remember, Desmos told me the answer is 9. And the order of operations is parentheses, exponents, multiplying or dividing, adding or subtracting. Where would I start here? What would I do first? The Desmos told us it's 9, so we know the answer. So if you have a theory of how it goes, I would check it and then see how we could get 9. What would we do first? We could multiply 1/2 times 16. We could add what's inside the parentheses first. Hint, 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 because that's what order.
Add the parentheses.
Yeah, thank you. Thank you. I should probably stop talking so you guys can answer, right? We would add the parentheses. So we're going to go 16 plus 2, which is 18. So we have 1/2 times 18. And then half of 18 is the same as going 18 divided by 2. Exactly the same. And that does get you 9. Cool. Yay, Desmos. Right? I need more guys. It would help me if I could have a little more answering, please. It'll help us get through much quicker. Okay, look at this beast of a problem. Blah. Look at this thing. Ew, gross, right? Somebody agree with me. Somebody has to type gross because it's a gross problem. Just looks gross. Ew, good job, Freya. I agree with you. Yes, Vlad, you're absolutely right. It's just gross. This is a problem where it really helps to use parentheses when you enter it because it's a negative. So all we're going to do, okay, they want us to evaluate this for this. So that means wherever we see an x, what are we going to replace it with? What do you guys think?
-2.
Yes, very good. We're going to replace it with -2. So here's my problem. Sometimes you could even write out the problem first. And then you could fill in that parentheses -2. Here it doesn't really matter. It's just 2 sets, but it still helps. So now if I did order of operations, I would always stick with those parentheses first. But remember, we don't have to do that. We can take Desmos, which is our friend, and we can type this right into Desmos. It's so cool. And believe it or not, I am not a spokesperson for Desmos, I promise. So we're going to do a double set of parentheses, -2 plus 5. Now here comes the squared. We would hit this a to the 2 button. Oops, not that. And then minus 3 times. And here you could do your double parentheses plus, and then here's our square root button. 9. And we get 18. 18 is what Desmos tells us. So let's do our order of operations to do that. Okay, order of operations tells us we do parentheses first. So I'm going to evaluate this guy here, -2 plus 5. What's -2 plus 5?
3.
3, perfect. So we have 3 squared minus, I could do this parentheses too. What's -3 times -2? Or excuse me, 3 times -2. What's 3 times -2? -6, right. Very good. And then what is the square root of 9? What's the square root of 9? What was squared to give you 9?
3.
3. Yep. And then we can go a little further. 3 squared, we know what that is. That's 9, because we just did the square root of it. A minus minus together, that changes to a plus. And now, since we just have addition left, we're going to start from the left and work our way to the right. Guys, that's something that always confused me. If you just have addition or subtraction left, you always go left to right. So we go 9 plus 6, that gives me 15 plus 3. Is that 18?
Yes.
18! Woohoo! Is that making sense, guys? If it's making sense, go ahead and write yay in chat. Y-A-Y. Type yay, yay. Chicken, I'll take that. Okay, type a nonsense word. How about that? Just absolute nonsense. Potato. There you go. That works. 8. Swoopy. Whoopee. No, I don't know. Shark. Ooh, that's a good word. That's a tough word. Okay, look at this one. Ugh. Gross again, right? Gross, gross, gross. We're definitely going to use Desmos to our advantage here, okay? So this is what we want to evaluate right here. And according to up here, every time I see an X, what am I going to replace it with? 2, right? And every time I see a Y, what will I replace it with? A 3. Good. Oh, Nathan, that's totally fine. I will post the rest of this video on Moodle. Bye. Bye, Nathan. Okay. So we're going to do that every time, and I'm going to just write the problem out. And every time that I see an X, I'm going to replace it with a 2. And I'm going to use parentheses here because see this 5X? If I just put a 2 in there, it looks like the number 52. It looks super confusing. So I'm going to put parentheses because that tells me I'm going to do what with that 5 and the 2?
Multiply.
Yeah, I'm going to multiply. You're right. Whenever you have a number right next to a variable, that means multiply. Good. And then we're going to subtract. Now here's an X. I'm going to put a 2 in. And then here's a Y. I'm going to put a 3 in there. And I do it all with parentheses. And here's the parentheses that's in the problem. 3. Go on the bottom there. I'm going to take 2 to the third power times Y, which is 3, minus 5 times 3. What do you guys think? Is this a good Desmos problem? Desmos. If you think it's a good Desmos problem, type Desmos. If you don't think it's a good Desmos problem, type bubbles. It's really hard because you might want to really type bubbles. I get it. But what do you think? First person to answer is how we'll do it. Desmo bubbles. Ooh, Freya, you got me. All right, we'll do both. Ha ha. Ha ha ha. No, I'm just kidding. I was going to do that anyway. So we're going to go ahead and type it in. And since it's all in a fraction, I'm going to hit that fraction button first. And I'm going to type in parentheses 5 parentheses 2 minus parentheses 2 parentheses, not at symbol, 3. And then there's the closed set of parentheses. And then I raise it to the third power. So I'll hit this A with a little exponent B. And then type in a 3 for my exponents. And then you type the down button to get to the bottom one. So 2, and raising that to the third power. 3 minus 5 times 3. Oh man, this is a great one. Look at that. That looks confusing, right? And if you guys know Math Excel does not like decimals. So what we're going to do is we're going to hit this little button next to my decimal. Very good. Very good. Good job, you guys. Some people are calculating along with me. I love it. Good work. So we get 64 over 9. Now let's do it with order of operations. So 5 times 2, that would give me 10. 2 times 3 would give me 6. 10 minus 6 is 4. So on the top, I'm really going 4 to the third. 2 to the third power is 8. 8 to the third, 8 times 3, excuse me, is 24. And 5 times 3 is 15. So 24 minus 15. 4 to the third power is the same as 4 times 4 times 4.
64.
Which is 64. Very good. And then 24 minus 15 definitely gives you 9. So, no reason to like freak out about this because Desmos really, really helps here. I would just make sure you always plug in with those parentheses. Okay, you still have to know the order of operations, and we'll go through that, but use Desmos to help you get it done. I mean, why not, right? Calculators are allowed. Does anybody have any questions on that? Okay, so we already talked about the order of operations. Go ahead and write it down if you don't have it. And honestly, a better way to show the order of operations is like this: parentheses, exponents, multiply and divide, add and subtract. Because when there's just multiplying and divide left, you always go left to right. And when there's just add and subtract left, you always go left to right. And that will definitely mess some of you guys up. But if you're using Desmos and you type it in exactly how it looks, you should be fine. So if you do not know the order of operations, you're definitely writing this down. Oh, of course you can. Thanks for letting me know. Of course. You go right ahead. Yeah, you go right ahead, guys. And whatever, if you ever have to, take a break or excuse yourself, you could just type in BRB. Totally fine. Or what Emma just did. Trust me, I get it, especially today when I'm feeling so fantastic. Ugh. All right, so we've got this problem down here, and we're going to use the order of operations to take care of it. Some of you might have typed it into Desmos, and that's great. If you did type it into Desmos, does anybody have what it should equal when we evaluate it? And if you don't, that's fine, because I did not tell you to do that, but it's okay if you did. A good day. We're pretty casual here. So we're going to use the order of operations. What would I do first? Order of operations tells me parentheses. What does that mean? What would I do? Yes, very good. Thank you, Freya. We're going to solve the ones in the parentheses. And what's really cool about this is you can always go left to right. So if you have more than one set of parentheses, you just go left to right. Oh, you said that perfect. Said that perfect. You good catch though. You said solve. We really should say evaluate, but it's okay. That's totally fine. But really good catch. Seriously. That's awesome. So 5 plus 4, that's going to give me 9. And then we're going to solve the next set of parentheses, 3 times 8. What's 3 times 8?
24.
24, perfect. And now we just have subtraction. We're going to go 9 minus 24. What is 9 minus 24? And remember, this is the same as 9 plus negative 24. Negative 15 is right. Very good. And I'm always gonna okay. So we're gonna go 9 minus 24. Negative 15. Yes, perfect. Very good. Any questions on that one? All right. Now we're going to do this one. Now, sometimes you'll see this little caret symbol. That means that Jen was typing out her slides and couldn't figure out how to make an exponent. But whenever you see this little caret symbol, it means raised to the second power. So we'll go 14 minus 6 squared plus 3 plus 5. That's what that really means. So go ahead and think about that one for just a second. Emma and Freya say 72. Guys, I apologize. My son is switching schools today, so I'm getting a lot of texts from his teacher. So he has to bring all his stuff home too. He is switching, unfortunately, because of his behavior. They can't deal with the meltdowns, I guess. He's been getting really aggressive, and yeah, he just needs a school with a lot more support. So he's switching to that school. Yeah, it makes me sad because I'm like, I don't know. I feel like they could figure it out, but a lot of you guys have had issues with regular brick and mortar schools. Yeah. So you know that some schools just, you wish things could be different and they really aren't. Yeah, yeah. I wish he could stay at this school because this is a regular school, but he's going to a school that has all kids with special needs, and you know, we'll see how it goes. I don't know. So anyway, yeah. So we think it's 72. So we'll check that. So I'm gonna do the parentheses first. So 14 minus 6. What does that give me? Yeah. Yeah, Audrey, we had similar situations like that where he would have a huge meltdown and he would have to, the students would be evacuated to, it was just a big to do. And, you know, when that's your kid, you feel terrible, but can't help it. That's autism for you, you know? You just handle things differently. So, and that's 8. Yes, very, very good. And then squared. And then we're going to do 3 plus 5, which is also 8. Cool. So then 8 squared, what's 8 squared?
64.
64. And then we're going to add 8. Does that get us to 72? Yes, sure does. Very good. So 72. Beautiful. Good job, you guys. You guys who are finding the answer are using Desmos? Yeah, and that's cool. That's what I want you to do. I want you to find it easy. That's good. Oh, you're not? Okay, cool. Oh, I was just wondering if you're using the Desmos website. Cool. That's great. Good. It's there. It's a good resource for you, right? It's so quick to type stuff in. Like, quick homework this week. Woohoo! All right, so this one is the same deal. We can type it in. See how this 8 minus 4 is under this square root symbol. This is just like saying, oh, sorry, hold on, I'll go back. This is just like saying there's parentheses around there. So we'll do parentheses from left to right. So we'll go 8 minus 4. What does that give us? Four, good. So then we have the square root of 4 plus 4.7. What does that dot mean again? What is the dot telling us to do? Multiply. Yeah, you'll see dots sometimes. Dots or parentheses. So what is 4 times 7? What do you guys think? What's 4 times 7? 28. Good. And 3 squared?
9.
9. Yep. 3 squared is the same as 3 times 3, which is 9. And some of you might do that in a different row because technically it's the next step. But since it's separated by this subtraction symbol, it really doesn't matter. It's okay to do it in the same line as your parentheses. So now I got to take care of this square root. What's the square root of 4? What squared gives me 4? 2. Yep. And now you guys see how there's just addition and subtraction left? I'm going to go from left to right. I'm going to first go 2 plus 28 and then subtract 9. What would I get? 21? Guys agree? 21. I agree with that. Very good. Very, very good. Pretty easy. Not too bad. Oh. Okay, what do you guys think? Go ahead and try this one. Give this one a try. And I'm going to say in fraction mode like this, it's almost like the top and the bottom have parentheses around them, even if you don't see it. Go ahead and give it a try. And if it's okay, I'd like to use my popsicle sticks and call on someone, if that's okay. If you don't want to answer, you can say pass. That's okay. All right. Audrey, what do you think? And you might still be calculating. I might not have waited long enough. Sorry. Sorry if I didn't. And, and remember, for this, you guys could use Desmos, or you could just go through the order of operations. Totally up to you. And I'm going to ask a few of you guys just to see if we get matching answers. Audrey, you still calculating? What do you think? And pass. Oh, sorry, go ahead.
Does the line means divide, right?
Right. Good question. Very good. That does mean divide. And you can pass. That's okay. Vlad, what about you? Pass, no problem. No problem.
Can I answer it?
Yeah, go ahead.
I got 2.
2? Cool, cool. Let's see. Emma, did you get 2? Freya, what did you get? Awesome. All right, let's check it. Let's check it. So we'll do the exponent first when we do the parentheses there. So we'll go 6 squared, that gives me 36, minus 8, and then 3 squared is 9. And now I hate doing subtraction and addition in my head, although I know this bottom one is going to be 14. But I would actually go to my calculator and say 36 minus 8, and that's 28. And then this line does mean divide. It means you're going 28 divided by 14, which is 2. Very good. Very, very good. If you use Desmos, you would type it in exactly how it's shown. And I'll use Desmos for evaluating the second question, because I want you guys to do it just one more time. One more. So go ahead and use the order of operations to simplify. And I don't like that there's numbers here. So yeah, we'll forget about that. But you could either, the answer will either be 5, 7, or 14. So go ahead and try this one. You can use Desmos or your calculator. Sometimes it's easy to use your phone calculator for the top part and the bottom part, but again, I really like the Desmos calculator. I really do, because it shows you exactly how you write it out. And I'm going to write the problem just so when I use Desmos, it's on the screen. And once you get an answer, go ahead and type it in chat, either 5, 7, or 14. Yeah, you can say, anybody can say, go right ahead. Freya says 7. Do you guys agree with her? Emma says 7. Cool. What do you guys think? Are they correct? This is our last order of operations one we're doing, by the way. We're almost done. And then we just got to write down some properties and we're good to go.
$28.
What did you get?
28 divided by 4.
Very good, which is 7. Very good. So Addie agrees as well. Good stuff. All right, so this is what you would see if you did it in Desmos. So we would type in the fraction bar, and then you're going to go 20 minus parentheses. And if you're looking for how you type in a negative in Desmos, it's just the subtraction button again. So you'll use the subtraction button for both the negative and a subtraction, which can throw people sometimes. Very good. It's 7. Yay. 7 it is. Good stuff, you guys. All right, last part of our lesson is properties, and this looks really wordy, but I'm going to tell you exactly what to put in your foldable, okay? So you guys need your foldable. All of this stuff is going to go in there. When we write the property, like the rule with the algebra symbols, that's going to go on the inside, on the back of the tab. So on the tab where you wrote multiplicative identity, on the back of that tab is going to go the rule. And on the back page that you did not cut is going to go your example. Okay, and I'll sketch it out as best as I can. So the multiplicative property tells us no matter what, when you take a number and you multiply by 1, you're going to get that number again. So I really liked this visual. Oh, sorry, guys. So sorry. Why does that always happen to me? Okay, I really liked this visual because it shows that you're multiplying all of these numbers by 1 and you'll get that same number back again. So the rule that you're going to write down on the back of your tab, so here are your other tabs. You're going to open the multiplicative identity one. Okay, that's what this picture, this lovely picture represents. So the rule is going to go right here, and the rule is this guy right here. A stands for a number times 1 is the same as 1 times A. And either way, you'll get A again. So that's the rule that you're going to write down on the back of that tab. Okay, and you guys can look at my camera for some verification there, if you can read it. There we go. So this is the back of the multiplicative identity tab. I open it, and the rule with A times 1 is the same as 1 times A is A. It's right there. It's basically saying whenever you take a number and multiply it by 1, you get that same number again. And then here on the page that you did not cut, we're going to put our number example. Okay, so our number example is if we're doing 1 times 3, well, that's exactly the same as 3 times 1. You're going to get the same answer either way, right? And then that will give you 3 again. It's just a fancy way of saying whenever you multiply something by 1, you'll always get that number again. You might be saying, why are we going through this? It's because it's stuff that you already know. Now we're just kind of labeling it with a rule. Is everybody clear on what you're supposed to write? I just kind of threw a lot at you, I know. Okay, good. Good. All right, when you're done, if you could just write done, that would be lovely. I don't want to turn it too quick. Yeah, you don't need to write all of these words here. Just need to have the rule. Anything times 1 is the regular number again. Okay, I'm seeing a lot of dones, so I'm going to switch it. If that was not you, let me know, and I can get the writing back on there. Okay, so now we have the commutative property, and we're dealing with the commutative of addition and multiplication. So you guys will notice the commutative addition is first. So the rule that you're going to write down that goes on the back tab is this one. This is the rule. This goes on the back of the tab. A plus B is B plus A. It just means you can add in any order. And then here is your example. So all of the examples are going to go on the piece of paper that you did not cut. And the rule goes on the back of the tab that you did cut. And multiplication, it's exactly the same way. Commutative multiplication means you can multiply it in any order. If I did A times B, I will get the same answer as if I go B times A. So 2 times 6 is 12, and so is 6 times 2. You can add and multiply in any order. So with this slide, you're going to fill out 2 tabs here. So this is the back of the tab, and this is the example. Does that make sense, guys? Okay. And when you are done, type in an exclamation point to let me know you're done. Perfect. So I've got 3 people who are finished with this right now. When you are done, if you could please type an exclamation point. 4 people. Six people. 7. How many people do we have here today? Oh, we have 10 people. So 2. Okay, that's not bad. So I'm going to assume you guys are all done. Okay, the distributive property tells us that if you have a number on the outside of parentheses like that, you can distribute or multiply the number in front of the parentheses by each part. So the rule, here's what you're going to write on the back of the tab. Okay, so on your foldable, we'll put some letters in for it. So instead of 5, we'll say A times B plus C is equal to A times B plus A times C. That is the rule. That goes on the tab. And then the example is this 5 times x plus 6 here. So you'll say 5x plus 5 times 6, which is 30. So the rule that goes on the back tab is this guy here with all the letters. And the example has the 5, the x, the 6, and the 30 in it. So it just tells us when you have a number on the outside of parentheses, you can multiply it by each number on the inside. It's like you're sharing candy. That's what I always think about. So the 5 has candy, and they're sharing it with the x and the 6. And when you are done writing this rule, if you can type the letter O. Why the letter O? I have no idea, but the letter O. So I have 3 people who are done. We're almost done. See why we made the foldable? Ooh. See why we made the foldable ahead of time? It really helps kind of go quicker. You know, somebody just texted me a question, and I want to address it because it's a really good question. They said, isn't there supposed to be parentheses? And you're right. Technically, if I was following the rule, it would look like this: 5 times x plus 5 times 6. And what's down here is what you get when you simplify. 5 times x is 5x, and 5 times 6 is 30. So you're right. Technically, according to the rule, it should be this. But the simplified version is that 5x plus 30. Good question. Very good question. Cool. Good stuff, you guys. All right. Next one. Okay, this is the multiplicative inverse property. It's pretty crazy. It comes up a lot, especially in higher level math courses. So don't worry about all this for every number. That's confusing. If you take a whole number and if you multiply it by a fraction where there's a 1 on the top And whatever whole number you had out front is on the bottom, you're going to get 1. So this is your rule. Your example would look like this. Let's say I had 7, and if I multiplied by the reciprocal, right, or 1/7, I'm going to get 1. That works with any number. 8 times 1/8 is just 1. Anything like that. And the reason is because when you multiply a whole number by a fraction, remember, that whole number can be turned into a fraction by putting it over 1. And then it kind of just cancels itself out. So this is called the multiplicative inverse property. It says if you take the whole number and multiply by a fraction with that whole number in the denominator, you're going to get 1. If you are done writing this one down, if you could type the letter B. B as in bubbles. B, B, B. B as in boy. B as in bottle. I don't know. So I only have 3 who are done. Okay, Emma's done. Cool. All right, cool. I'm getting some more B's. Good stuff, good stuff. All right. Now the additive inverse, yeah, right, B as in Beyonce. You're right, that's a good one. Says if you add a number and its opposite, you're going to get 0. That's what it says. So this is the rule, and this is the example. So adding a number plus its opposite, so this is a number, and this is the opposite, will give you 0. So when you're done typing this one, type the letter A, as in apple. A as in awesome. We're almost done. We have 2 more. A as in Addie. A. That's what Vlad says. A. I like that. A as in Addie. I should have said that. Jeepers. A as in additive. What? No. Just 2 people are done? What? Okay, good. Evan, Cade. A as in algebra. That's right. Okay. A as in ah. All right. So the last 2 properties are these here. Basically, they just say you can add or multiply numbers in any combination. That's it. So if you have 3 or more numbers, it's associative. If it's just 2, it's commutative. Okay, so the rule for the commutative of addition is right here. And the example is down here. Here is the rule and the example. So all those parentheses are telling you is it's saying those are the ones you're doing first. Okay? And these are the last 2. I'm just going to show you one more thing and you are free to go, my friends. You know what? I'll just say it here. I'm going to skip ahead just for a quick second, then I'll go back. That way I can excuse you guys. If you have a question like this, where it says use the commutative property to find the answer, just type it in Desmos. That's what I would do. Okay, so if you have something like this, just type it right in Desmos. And with that, once you are done writing this on your foldable, you are free to go. Because that is all I have for you lovely people today. Thank you for listening and putting up with my stuffiness.